Okay, now let's piggyback off of that previous example and try to compare some proportions. Now, in our class, which is our Math 38 online through the Portmont right now, we have 22 students, and I just looked, 7 of them currently have A's, as a 90 defined as 90% or higher. So notice that 7 out of 22 is 7 out of 22. Well, that's 31818181818. So that's not quite as high as my overall percentages, which were close to 34%. But we're not done yet. We still have a little bit of work, a week and a half left of work here to catch up. But it's still higher than the 20% baseline that we presumed. But that's not the question we're going to ask here. The question I'm going to try to ask here is the proportion of students getting A's in the Portmont format different than my traditional courses? Because I have a sample from my traditional courses, the 62 out of 181, and I have this new sample from Portmont. Now, our sample from Portmont is actually a little bit low to be able to use this theory. I need some more data. I have to have 10 successes and 10 failures, but we'll pretend that it works just so I can get the idea of the hypothesis test running. So let me scroll this down so we can actually see. What we're going to do in this case is I'm going to start off another hypothesis test, and this time my null hypothesis, H sub 0, is going to be something like trying to say the two proportions are the same. Our assumption is that they are close to each other. P sub 1 equals P sub 2. And this is, of course, in distinction to, or drawn in contrast to, the alternative, which would say that there is actually a difference between the two. So that would be something like P sub 1 is not equal. I'm doing a two-tailed test, P sub 2. I'm not testing to see if one class did better than if traditional is easier, better, or different than Portmont, but just that it's different, that there's some difference between them. So I still got to go through this idea of getting a z-score, and I'm still going to have to go through and get a p-value. So I'm going to do that just like I did before, but now I'm going to run two samples. Notice I have two proportions floating around. So coming back to the calculator, let's clear this key press history so we can just see how we're going to work with this new data, or this new analysis. I'm going to go to Stat, Tests, and this time I have two proportions that I'm testing. The two proportions were the 62 that I had out of 181. That was my traditional classes. And now I have this new Portmont sample that has 7 A's out of 22. And I'm going to wish to choose to test if they're not equal. Remember, that was my choice from the beginning here. So I'm going to test to see if they're not equal. Not that one did better than the other, but just that there's no difference. So when I do that, let's see what I get here. A z of 0.2278, z-score of 0.2278, which implies a p-value of 8. Oh, look at that. That's gigantic. 8198. 0.88198. Notice that is ridiculously higher than the 0.05 threshold. So that means that my null hypothesis, that the two classes or the two types of students have the same approximate proportion of A's, is actually not ridiculous. This is reasonable. In fact, it's almost likely with this huge p-value. So that means I don't have enough evidence to say that this is not true. So in my conclusion, I'm going to say I strongly, in some sense, failed to reject the null. And I don't get to say that I've proved the two classes have the same proportions. That's impossible. But what I can say is I do not have evidence that one type of format has more A's than the other type. There are too close to each other. They're a little bit different, right? One was 31%, one was 34%, but they're not ridiculously different. And in particular, according to the statistics, I do not have statistically significant evidence to say that the proportions are different from each other. Now, even though this is a really high p-value, and I'm pretty sure that the two classes are the same, I may have made an error. The potential error here is a type 2 error. If I fail to reject the null, then the error that may have been made would be a type 2 error. I'm pretty doubtful that that I made an error because the p-value is so high, so far away from 0.05, but if I did make such an error, that's the type of error that it would be.